I'm not overly worried about that. We'll let that sit a little bit. So before I can load the column, I need to let the meniscus here, I want the bottom of that meniscus to be right at the top of the sand. And this pipette is for my pet ether. There's a little bit of silica around the walls still. Drag that down. So I don't really want to use any more volume. Even though it's not completely dissolving. Let's put that on there. I'm going to stick this in the Vortex Genie, really give it a buzz, see if I can get that to dissolve a little better. This is the classic problem with chromatography, is getting your compound of interest to dissolve in something that will allow you to transfer it to the column without being so polar that will also drag it through the column way faster than you want it to. So what I'm trying to do is mix that so that I get a pipettable liquid that won't clog the pipette. It looks like it's going to be a bit of a challenge. And then I want to add that before the column goes dry. So it may be necessary for me to stick my finger over the top of that. And it just doesn't want to dissolve in that eluent. Classic problem. Very hard to solve. So it looks like I'll need to add more ether to get it to dissolve. This is always the problem you fight, is that it won't go into the nonpolar component of the mixture. So you end up having to add it in the polar component of the mixture. And as I said, when you have too much of the polar component of the mixture, then it doesn't separate. It would be ideal if this stuff would have been willing to dissolve in petroleum ether. I knew it wouldn't dissolve in petroleum ether. I was kind of hoping it would dissolve in that 1:2 mixture, but no such luck. Alright, so that's completely dissolved now. That will enable me to add that to the top of the column. And it's a little bit more of a layer than I'd really like, but inspired by our lack of choice, that's what we're doing. And we don't need those anymore. So now I also need to let that drip. And I want to make sure that it actually goes into the column. So I'm going to wait for that meniscus to hit the top of the sand again. And then I'm going to flush it in with a little pet ether. And by using some pure pet ether here before I switch to the mixture, I will also counteract the effect of adding a little bit too much volume. So the key here is not to let it go dry. You see there's a little crack already. I want to make sure that crack doesn't get any bigger. So I want to flush that in so that my compound is well and truly loaded on the column. And minimize the air bubbles. Alright, you see I got a little bit of an air bubble, which I will get rid of with some pressure in a minute. So it's pretty much colorless, clear and colorless above, which means I think I've got my compound on. And I'm going to use some air pressure to try to get rid of the crack. You don't want much. You want to be able to feel it when you release it, kind of hear it, but only once you release it. So now I'm going to fill that up carefully so as not to disturb the top too much with petroleum ether. And I'm going to start that dripping into my first tube. And then I can apply some air pressure, which will hopefully get rid of that crack at the top of the column and also speed up the flow a little bit. So I can run this column fairly quickly by applying some air pressure. You can use a much finer grade of silica than we have here. Ours is probably 60 to 200 mesh, which is good for gravity column chromatography. You may have seen in some of the papers that talked about flash chromatography. That uses a much finer size silica. So that actually requires air pressure. And so I'm filling that up to about that 5 milliliter mark, 6 milliliters maybe, and then I'm going to scoot it over to the next one. And you can see that the color is going down. You can see that that air bubble is coming out. So I can run this. Right. There's no disadvantage to running it fairly quickly. And scoot that over, but I do have to make sure I don't let it go dry. So just release the pressure. And if you release the pressure slowly, you don't get air bubbles. If you release it too fast, that little crack there is going to explode upwards. And that would be bad for business. I'd get lousy separation. And if I don't get great separation the first time, I can always run another column. If you're a graduate student in organic chemistry, you run one of these every day. Maybe two. Because chromatography is probably the most common method for purifying compounds, especially liquids. If they're high boiling and you can't distill them, column chromatography is pretty much the only way. For solids, you hope you can recrystallize. So my first 5 tubes are going to be pretty much pure petroleum ether. And I don't really expect anything to come off in those first 5 fractions. But I'm hoping I'm going to slow the vanillin down by pulling that extra ether that I had to use, because I probably used about a milliliter of the mixture and 2 milliliters of ether in the end to get it loaded onto the column. And you can see that's going pretty quick. I get about 2 tubes before I have to refill. I'm about to switch. Since I'm about to switch the eluent, I'm going to let that meniscus go pretty much all the way down and add the first little bit. So this is what's called a step gradient. I'm going from pure PET ether immediately to a 1 to 2 PET ether to diethyl ether mixture. If we had a fancy pump assembly, we could gradually change the composition by having 2 different pumps pumping the solvent in. And if you've got money, that creates a nicer, smoother result in the column. So now I'm going to add my 1 to 2 PET ether diethyl ether mixture, which is increasing the polarity. Everybody should start moving a little faster. And once I have enough in there that I can be sure to pour it without disturbing the top, then I can pour it in. Because there's much art as there is science to running a column. And you will be terrible at it the first time you do it. Which hopefully will be this spring. We'll see how the in-person versus online balance goes. So I'm probably actually collecting closer to 6 milliliter fractions than 5. Going a little bit further above the pins than that 5 milliliter measurement was. And especially on the early fractions, since I think nothing's coming off yet. that's justified. It's not quite flat, so it's a little hard to adjust the flow rate. In the real world, of course, you have needle valves and pressure adjustments and all kinds of sophisticated equipment. It makes this a little bit of a cleaner process. But we can still get decent separation even with our rather limited tools, as long as the RF is different enough. You'll notice that by going through that kind of serpentine, I don't have to switch from this tube to that tube. It prevents me from kind of spilling. I just got to keep an eye. Right, basically 2 tubes and then refill. At this point it doesn't matter as much if I disturb the top, because my compound's down here somewhere. Sometimes when you're doing solids, especially with really volatile solvents like these, you'll notice a little bit of solid collecting around the tip. And I want to make sure that that solid goes with this fraction rather than, you know, waiting until the next fraction. So it's sometimes worth rinsing the tip a little bit. And what happens is the solvent kind of crawls up there. So I definitely have something coming off here in tube number 11, because I can see that solid collecting. And hopefully it's pure vanillin and no cinnamic acid. So I'm going to actually start collecting slightly smaller fractions now, and occasionally rinsing that down to make sure that that solid goes with its proper tube. And what we're hoping is that the vanillin comes off before the cinnamic acid starts, right? The last of the vanillin comes through the column before the first of the cinnamic acid. The reason I'm rinsing off the tip is if there's a little bit of vanillin there, I don't want it to stay there, and then I'm collecting cinnamic acid and all of a sudden that vanillin lets loose and gives me contaminated fractions. I may not get perfect separation. There may be some fractions that have both in them, but at least we hope we have some pure fractions. You can see that this would take a long time if I wasn't running the air pressure, because the drip rate without the air pressure is pretty slow. And that fraction was a little bit large because I was messing about. It's probably more like 7 milliliters, that one. Rinse that little tip off. I don't know if you can tell that it's a little bit colored, at least it was. I've got a perfect position there to get a nice flow rate. And some fractions that maybe a little bit under 5 milliliters on those last couple. Often you'll run a step gradient if you have two compounds that are fairly different in RF. You saw that one paper where they used dichloromethane and then they used some dichloromethane methanol mixtures. Right, so they take the nonpolar stuff off first and then they increase the polarity of the eluent to try to get the more polar things that are sticking to the stationary phase. It doesn't look like I'm getting a lot of solid now. Hopefully that's a good thing. Means my compound is mostly off, we think.